I think we're live. Let's see. Alright, let's get started. So today I'm just going to be building some circuits with this new FSR Adafruit Square force sensitive resistor that I got. So hopefully what we'll be doing today is we'll be connecting the wires from this breadboard to the Raspberry Pi and also the FSR. And ideally when we press down on the FSR, I should be able to pick up that signal from within the Raspberry Pi. So let's see if we can do that today. How do we actually connect these? Oh shit. Let me just take these out. Put these on the side. Take more. I think we need to use male to female wires. Okay, female to male and female to female. So we have, these are male to male. These are male to female. Okay. So I'll put these on the side. Male to male, I'll put on the right side. Let's see. So I need male to female, male to male. I can just put away. Okay. I don't think this is actually going to stay, but we'll try it. This is not going to work. Oh no, there we go. Okay. So I have 4 sensor resistor on one side. Now I need to connect this to Raspberry Pi. Let's see. Okay. So I'm gonna need the female to male. Let's see. What's the difference between... I don't know if this is super visible. Let me actually put the tutorial in here. Okay. Let's see. Okay, they are perfect for detecting touch and qualitatively measuring rate and relative changes in force and pressure. Let's make this smaller. There we go. Okay, that's better. So let's see. Force sensitive resistors are remarkable electronic components. Name me a better. Stability comes from the fact. pretty much exactly what I want to do. This will explore two methods of control when utilizing force-sensitive resistors, simple and analog. The endpoint of the simple setup will know exactly when the resistor is under force/pressure. The endpoint of the analog setup will let us detect different magnitudes of force or pressure. See below for the contents of this guide. How they work, what you need. Simple and analog setup. Simple on-off setup. Bro, this music is so loud for me. There we go. Okay. Reading analog data from force-sensitive resistor. Where to now? Downloads and addendum. So come add a rugged touch interface to your next project. Create a robot with sensitive resistor with a square sensing area. Okay, same one that I have. Situated next to a Raspberry Pi 4 Model B, same one that I have. Same for all FSR components. The square FSR will vary its resistance depending on how much pressure is being applied to the sensing area. The harder the force, the lower the resistance. When no pressure is being applied to the square FSR, its resistance will be larger than 1, is that a mega ohm? It can then range from 100 kiloohms from light touch to a few hundred ohms, okay? This square FSR can sense weight anywhere in a range of 100 grams to 10 kilograms. That's perfect. Resistance is very stable when the pressure is fixed, and the readings are very repeatable. Okay, so I have both these. Note that these FSR components are not a replacement for load cells or strain gauges. I have a load cell. Yes. FSR components will never be suitable for precision. Okay. While FSR can often be used for high resolution dynamic measurement when low weight and footprint are desirable, only qualitative results are generally attainable. Okay. That's fun. Now, as incredible as Raspberry Pi single board computers are, by default they have no way of reading pure analog signals. This is fine for our simple setup, as will indicate whether there is pressure on the force resistor or not. However, to see the gradient as the pressure increases, we will need an ADC, which I do have. That is here. Analog to digital converter. This is the HX711. Perfect. I don't think we need that in this case though, because I just want to see if something's on the resistor or not. I don't really care about the exact weight. Blah, blah. An ADC board, like this one, converts analog signals into a digital representation so that they can be read and processed by the Raspberry Pi. Most sensors like temperature, sound, microphones, or force. Yeah. As always, okay. How they work. These FSR components have a huge amount of resistance at normal state, yet when they are pressed, they drop resistance significantly. Okay? The best way to understand how it is doing this is to separate into base components. Every FSR is made up of layers. Okay, these are an active area layer. Got it. Usually a flexible PCB with well-considered traces. A pressure-sensitive conductive film layer. So that's this last one. Okay, and an adhesive layer keeping it all together. You can see an exploded view of these layers as well as a graph showing the expected response due to force in the image below. Okay, resistance is very high when nothing is being pressed. Then someone presses it, resistance drops, and conductance increases. Sure, yeah. I'm not an engineering expert, but I'm assuming conductance is just its ability to conduct electricity. Let me see. Conductance. Conductance is the degree to which an object conducts electricity. Okay, yeah. These carefully considered traces on that flexible PCB layer are crucial to correct operation. Below is a FSR with a square sensing area and a microscope zoomed in version of the top of the square. I've altered the colors of the traces so you can more clearly understand that the two sides of active area traces do not directly connect to each other. Okay. Only when pressure is applied will electricity be able to flow easily as it can route through the conductive film layer. It can route through the conductive film layer. Which is this bottom layer. This particular square FSR has a greater than 1 million ohm resistance when unpressed. When the pad is pressed hard, allowing the electrons to flow through the conductive film, thus jumping it across the traces, the resistance decreases to about 20 kiloohms. That is an order of magnitude difference. Okay. I think this makes sense. Got it. All the force resistors that will be explored here are single point force sensors. From these, we can only obtain quantitative readings. The data obtainable from these single point resistors are as follows. Detecting or measuring a rate of change in force. Detecting or measuring a relative change in force, and detecting contact/touch. Any of this data can be used as thresholds to trigger an action or effect. Okay, yeah, that makes sense. Below is everything. 10K resistor. I don't think I have that. 10K resistor. Resistor. I don't think I have that. I need to switch the... I don't have a 10K resistor. What is it for? Can I just use a wire? Let's see. Okay, we can just skip that for now. Okay, one 10K resistor. I need jumper connectors, female to male, and female to female. So I have plenty of female to male. And I third, check. Micro HDMI to HDMI, check. Power supply, check. Mouse and keyboard, check. And I don't have this particular ADC, analog to digital converter, but I do have the HX711. So this should be fine. Should be fine now. So we have everything. Okay. To start, set up your Raspberry Pi as a desktop computer. I've already set up and used my Raspberry Pi, so I don't have to do any of these steps. Now before plugging in the USB-C power supply, let's make some connections from the GPIO to our FSR. You can see the completed hardware setup in the image below. I utilize a breadboard to do this. Be gentle when sliding the FSR components into the breadboard, as they are delicate on that connector side. I'm pretty sure I was careful. Once all those connections are made, power up the Raspberry Pi by plugging in that USB-C power supply. I wish these were bigger though. Okay, there we go. To clarify the above, the red jumper wire connects to a 5-volt pin. Okay. I can do that. So I'm gonna need, looks like 3 female to male. That's fine. I don't know the GPIO off the top of my head. Let's see. Okay, so we need to connect to the 5-volt pin, the ground pin, and the GPIO 4 pin. So that would be, okay. Pretty straightforward, I think. So let's do the 5-volt first. GPIO, we need the ground pin next. I can do that one. I should use the same colors as this guy. I think I have blue. I have my whole box of jumper wires. So, let's see, this guy used blue, black, and what else? Blue, black, and red. Okay. So I just need a blue one. He says we're gonna use the female to female. I have a whole stack here. But we want a blue female to male. Let's see. There we go. Okay, blue. I probably need a better way than just throwing all of my wires into a box, but it'll have to do for now. Okay, I don't need these. Let's get rid of the white wire. And I don't think I need the other ones. At least not for right now. Okay. So we're just gonna copy this as much as we can. Okay, so blue here. Blue goes to GPIO 4 pin. Okay, so it's 4th on the left hand side. I'm not gonna solder any of these, but we'll at least get it up running with the solderless breadboard. And then once I have the final project, I'll consider soldering this in. Okay. So first connection, next one is the black jumper wire connects to the ground pin, which is, I think it's 3 on the left. No. 3 on the right. Or we could do another one if we want to. We could do any of these. Let's see. I don't want to trip up the wires, so I do kind of want to spread them out. So we'll go to the 30. I think it's 34. So that is 4th from the bottom right. Okay. 4. So far, I feel like this is actually, I mean, we haven't gotten to the hard bits yet, but this is somewhat more straightforward than I thought. Okay. And then the last one is, so this will be on the other side, and it'll connect to the 5-volt pin. Okay, fair. This is so hard to see. And 5-volt pin is top 2 on the right hand side. Okay. The only thing we're missing is the resistor. I'll try to set up as much as I can without that. But I'll probably have to just order one. Let's see how far I can get without it. Yeah. Okay, so we set up the wires. This will act as our sniffing wire. That blue sniffing wire will tell our Raspberry Pi whether the FSR is being pressed. If you need, here's a fantastic website. Okay, we already used that. On the breadboard, be aware that all holes are in a connected column. Yeah, I mean, that's just basics of a breadboard. So all of the holes that are in a column are electrically connected. Yeah. I guess in this case, the way they have it orientated, it's a column, but in our case, it's a row. So all of the holes within each row are electronically connected. I don't know if this is catching up the exact setup, but we have the black wire and the blue wire are in row 2, and the red wire is in row 1. I think this will give a better view. And then the FSR is connected to both of them. So there are 2 inputs. He said to be careful, so I won't try not to rip this. There are 2 wires here. And the basic idea, once we have this set up, is that I will be able to tap on the FSR, and then from the Raspberry Pi, I'll be able to detect whether or not it's being pressed. And the idea here is, if you've seen the other episodes of the video series, you'll know that our goal is that we're trying to create, hopefully that will focus. Yeah, there we go. So we're trying to create an automated Pong table. So the purpose of using this FSR is that I will have one under each of the cups that are on the Pong table. And through this, I'll be able to detect once a cup is removed from the table, and then I can update the scoreboard appropriately. I've even, maybe next time I'll work on setting these up. But I was trying to find a material that I could use to go between the cup and the sensor. So I was having a lot of issues because a lot of the materials that I wanted to use were either not going to work, in that I wouldn't be able to detect the force difference, or they weren't waterproof, or there was a number of other reasons. But I was speaking to one of my friends and he suggested that I use a mason jar lid. So I went and I ordered like 36, not even mason jars, just the lids. It looks like it comes with the screw part as well. I don't need this, but I need this part. So the idea is that I can put the cup on this. It would go over the FSR. So let's see, FSR is here. The mason jar lid is here. Cup goes on top. And now I'm able to detect once the cup is removed. I think the hardest part is going to be, if you imagine like a pong table. I'm still not sure if I'm going to do 6 cups on each side or 10. But let's say we have 6 cups. These wires are very short. So, and I need to connect all of them to a Raspberry Pi that's going to be pretty far away on the table. So I think that's going to be the hardest part. I don't know if I'm going to have to do some sort of 3D printing to create like a full holder, and then I can, I don't know, have some circuits within this holder. Yeah, I don't want to get ahead of myself, one step at a time. But for right now, I just wanted to test out this FSR because in the previous prototype that I used a load cell, which actually, let me actually go get it. I used this load cell to create a scale. And the problem, as you can see, that is it's very big. So if I want to have like a pyramid of cups and I'm measuring when a cup is removed, it's going to be impossible with a load cell that's this big. And there's not really a way to connect it directly to the table and have it measure. As you see here, like I had to create a scale in order to use it, to where now every time I press down on this top wooden board, I'm bending the load cell, and in that case the load cell is able to emit a signal and I can calculate the weight difference. For my project, I don't need to know the exact weight. I can just say, hey, is there something on this? Is there something on the sensor or not? So basically on or off. And that's why I've kind of switched to this smaller sensor. This will fit under a single cup. And yeah. But yeah, like I said, the advanced circuitry of how I'm gonna actually have 12 of these going at the same time on a table. These wires are very short at the end, and they all have to connect to one Raspberry Pi. I don't even know if I have enough pins on. I might need a second one. So that's gonna be hard. That's gonna be the last step, though. I'm still in kind of the proof of concept phase. I'm gonna see if I can get this FSR working with a single cup and just test that every time I remove the cup, I can capture that and hopefully output a number on the scoreboard. I do have this scoreboard that came in. I mean, we're not ready there yet. I want to set up the sensor first, but I do have the scoreboard. It's a little small, so I don't know if it's going to be hard to see once I have everything set up, but it'll at least let me write some code to start with, and then worst case I can just get a bigger scoreboard. It's just that, like, there's not a lot of options for scoreboards. You either get these like tiny programmable number LED lights that are meant for like building an alarm clock, or you'll get something that's like huge that's meant for like a scoreboard at a little league baseball game, and they're like several $100s. So I haven't really been able to find much in between. And not only that, but like the scoreboard, it's not like connected to something. There's no like holder for the LED. It's just an LED that sits there, which I might have to start getting into 3D printing towards the end of this project in order to make everything look a little polished up. But we'll see. I have nothing. I have no experience with 3D printing, so that will probably be the hardest part. I mean, honestly, I had no experience with circuits before this either, so we'll figure it out once we get there. Okay, I just need to put this back in. I am worried though, because I don't think I was very careful the first time I put this in, and then this article, I started reading it, and it says that be very careful putting this into the breadboard. I don't want to I only have one of these, so I don't want to break it. Okay, there we go. Okay, so where were we? Now that you have the Raspberry Pi plugged in. Okay, I do have this Thani IDE. It's a Python interpreter software, and you can use whichever is your preference. In this guide, we will code using the Python program language. Click on the application menu and hover over the programming tab to find the Thani IDE icon. This will open up Thani. I hate that name, by the way. Then copy, paste, and save the below script into the coding area. You can also download all scripts utilized in this guide in a zip file found at the bottom of the page. The one thing I am worried is from the diagram so far is that they haven't actually used the ADC, the analog to digital converter, which it does say that's optional. I do have one. I don't know if I should. I guess we only need to use the ADC if we need exact weight measurements, which in this case I don't. So I can probably go ahead without it for now. So sure. Okay, let's try to see. This variable will be used to determine if pressure is being applied or not. Make this bigger. I don't know how visible this is. I don't know, I keep getting an error saying that the stream is not loading properly, but we'll see. Okay, this variable, let's make this bigger. Okay, this variable will be used to determine if pressure is being applied or not. Sure. Private input equals 0. Create a loop that goes on as long as the script is running. While true, take a reading from the pressure pad based on the voltage able to get to pin 4. Okay, so that was the that is the blue wire. Okay, so we're measuring the voltage that is going through the blue wire to GPIO to GPIO 4 pin. Let me actually, yeah. Okay, so input equals GPIO, input 4. So this takes the reading from that pin. If not, prev input and input. If the last reading was low and this one high, the pressure pad is being pressed. One question I do have is, so if it's not being pressed, it's always 0. It's not like just from the FSR if I don't use the analog to digital converter, and that's on or off. So I either get a number or I get 0. So in this case, if the previous input was 0 and the new input is not 0, then I print under pressure. Sure. And then I set prev input into the new input. And then I sleep for, is that seconds? Let me see. Python time.sleep. Python time.sleep is in seconds. Okay, so it's actually a lot. Every 10th of a second. We can always change that though. Save the above Python script as whatever you would like. It's saved as simple FSR setup. And put your system to the test by pressing the big green run button. Sure. Now, whenever you press the pad, it will respond with under pressure getting printed to the shell. You can see the result of pressing the pad with this script running in the image below. This script can readily be changed, providing you with a fantastic rugged button that can control almost anything. GPIO pins are the windows to controlling darn near every electronic system in this big world. Now you can control them all with an FSR. Got it. That's actually, yeah, that's pretty straightforward. I don't think I can finish the setup today just because I don't have the resistor. So I'll definitely make sure to get that for next time. I'm not super familiar. Resistor. I'm not super familiar with what the purpose of it. I don't understand enough about circuits or electrical engineering to understand the purpose of this. Resistors play a passive but important role in the circuits. You cannot
we're always in control of the when and where in our lives.
Oh shit, is that an ad?
I'll get you those figures today. Mom, check it out. I learned a new song.
Is this the song?
When and where you choose to do something can make all the difference. At University of Phoenix,
That scared the shit out of me.
balance work, family, and school.
Anyway,
Online classes 24/7. You get the freedom to learn when and where you want. Start your degree in tech, healthcare, or business today at
I'll wait for the ad to end.
phoenix.edu.
You cannot complete a circuit without resistors. It may appear unimportant to you, but it enables the designer to design circuits according to their requirements. Resistors not only divide the current, but also help to manage the voltage. Several resistors are viable in the market. You can choose according to your needs. A 10K resistor is one of the most demanded resistors. Let's dig deeper to know. You know what? I don't think I will stream League. I don't think so. I actually, you know what? I know for a fact that I will not be doing that. I appreciate the suggestion though. Let's see. A 10K resistor is a passive resistor, but is a great help in controlling the flow of electric current in the circuit. It is called a 10K ohm resistor due to the resistance of 10,000 ohms. Do I need this though? Yeah, I think I do. Actually, do I need this? Yeah, I've taken 0. So I am really struggling here. The problem is I have all of the other pieces. This is a force sensitive resistor, and I have that. And I have all of the jumper wires connected to the right pins. But yeah, I do need a 10 kilo ohm resistor here. The problem is I don't, I mean, I probably do need it. They wouldn't have included this if it wasn't necessary, but the problem is, like, is it just splitting the current? Or is there some other purpose that this serves? Like, can I just, this is a dumb question, but can I just put the black jumper wire into the other. I don't know. No, I'll definitely get the. I will be getting the resistor. I'm just trying to see how much I can get done without it for now. I mean, I can. I probably can't test the script. It looks good. At least I've gone through it. But at least I have everything else set up. Next time I will have the resistor though. I do have to finish that. What is I? What is I in that? Ohm's law. This would have been helpful if I remembered anything from first year of college in physics class. Or the current. I is current. Interesting. So voltage equals current times resistance. Yeah, so basically how this FSR works is that it has a high amount of resistance when it's not being touched. And then I was even going through, like earlier in the article, if you go through, it mentions that like once you press down on the top of the resistor, it will, these two pieces will be touching what's called the active area, which is on top, and then the conductive film, and the resistance drops dramatically. So as soon as you put your finger on this, the resistance drops to almost nothing. So in that case, do you think voltage is current times resistance? Huh, but yeah, conductance goes up. Yeah, I wish I knew what was going on. Yeah, I definitely need that. I definitely do need that. One thing I don't need, which is this, is the ADC analog to digital converter. I have one here. I feel like I remember Ohm's law. All that stuff blends in though. Bro, I need your I need your mentorship. Maybe I'll message you before the next step. I think I mean, I'm literally, this could not get any easier. I have an article explaining step by step what to do. It just sucks that the actual part of this that I understand completely is probably the simplest part, which is this like 10 lines of code. Half of it is just comments. That's like the part that I understand the most of what's going on. I will have to read up more on resistors though. Okay, where was I? I read through the code. Da, 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 da. I'll have to set up these packages as well. Bro, it could be a good team. I mean, you've done coding in Python. This is like very straightforward, I feel like. Plus the package, the GPIO package, does literally all of the work. Like, you literally just call gpio.input4, and that gets the current that's going into GPIO pin number 4, which is what our blue wire is plugged into. So literally all the work is done, not even by the person who wrote this, but by this package that they're importing. So it's like super straightforward. Yeah, so you just have to set up the pin. Yeah, literally the only thing I don't understand is I'm actually not sure what BCM mode is. But yeah, this is very straightforward. You're setting up GPIO pin number 4. That's we have our current going into GPIO pin number 4. And then in a while loop, which this is always running as long as the script is running, we just keep checking if the previous input was 0, which means it wasn't being touched, and if the current input is greater than 0, which means someone is pressing on this. And then yeah, we just print out under this string to the console. I mean, obviously our use case is a bit different because I'm not going to be printing out a string, but the idea will be I have a table of cups. This is FSR. Each FSR will be under a cup. So I have this this is a mason jar lid. Actually, Michael recommended using this. It was a super good idea, and that's why I have literally a box of just mason jar lids. It's like, I think this is like 36. So yeah. But yeah, I'll be able to detect once a cup is taken off of the table, and then I can update the scoreboard as needed. I think the hardest part will be just somehow I have to connect like 12 of these on a single table to... Right now I only have one Raspberry Pi. I might need more than one. But even just building that logistically to where if I have like, let's say 6 cups all touching each other, these wires are very short. So I have to figure out a way to connect all of them to a Raspberry Pi that's going to be like 2 feet away. I might need to build like some sort of structure that holds the cups, houses the sensors, and then also has some sort of like internal wiring, and then connect that to the Raspberry Pi. But we'll see. That will probably be the hardest part because I need like a custom holder. Because my use case is so specific. I can't just pick something up that will work on this. So I might have to get into 3D printing, which I've already spent so much money on circuits, Raspberry Pi, wires. I can't imagine if I have to buy a 3D printer. I've never heard of Terminal Box before, but I'm sure you can understand what I was about to say about Terminal Box. Let me see that. Terminal Box. Interesting. Huh. I don't fully understand how this... I don't understand how this will help though. I understand that's like routing wires, but like if I how are the I guess I just don't understand how this works. Let's see. how do I get the input though? Like that's like the biggest problem is that like if these wires are super short, right? And they all need to be connected to the Raspberry Pi. And yet they have to be in like a very specific formation. Okay, so you're saying like add like so I probably need to like solder wires to the end of this. Have like a female to male. Can you splice the... Can I splice it to be longer? I mean, the thing is like the current doesn't have to be super accurate because this is not like before when I was using I was doing a proof of concept with the load cell, and like this is a load cell right here, and this whole thing is a scale. So like once you put something on this top wooden board, the load cell will emit current proportional to the amount of force that's being applied to the top board. So in that case, everything was very exact. I was able to output the exact weight of what was being put on the board. But in this use case, like I just need on or off. So I know you're saying there's like a drop in voltage. I'm not sure if you mean like a drop in current. Then again, I'm not an electrical engineer, so my opinion is not worth a ton here. But yeah, I think that's definitely a problem of like optimization. For now, I'm just gonna see if I can get one cup to... So I have one cup on top of the FSR, and then just see if I can write the code to, when a cup is taken off, update the scoreboard from 1 to 0. Overrun a wire. Interesting. Why does this might be a dumb question, but why does the amount of voltage matter? No, actually, no, that makes sense. It wouldn't go to 0 though, because that's the... And this is the interesting part, is that if you see in this Python script that they're using, like the previous input is set equal to 0, right? And 0 represents no force is being applied to this sensor. And they're saying like, they're so confident that like when this is not being pressed, the previous input is 0. It's never like close to 0, it's exactly 0. Which I find very interesting, because when I was building the scale, even if there was no weight on top of the scale, it wasn't exactly 0, because there was always some current being sent just by having like these wires set up. So it would be something like 0.007 or something. But in this case, and like it seems to have been working, when this is not being touched, this is literally exactly 0. So there's no current at all, which is very interesting. And I think that's like the main difference. Like this sensor is supposed to be different from a load cell. This is not for measuring like this is not to be used for a scale. It does say that you can I think in like later, I mean, I won't be using this part, but because I don't need the exact weight, but later they are reading analog data, so they're using an analog to digital converter like I have here, and like I used for the scale. And I wonder if they are going to print out the exact weight. Yeah, it looks like they are. So choose a gain of 1 for reading voltages from 0 to 4.09 volts. It's 1. Interesting. Okay, so I guess they're... Yeah. Yeah, that actually makes sense. Yeah, so with the analog to digital converter, they can measure the exact amount of pressure. But for my case, I won't need that. So I guess it'll just be going through 0. It'll either be 0 or some number. Nothing close to 0 when it's not being pressed. Which is... We'll see. Bro, I can't believe I'm gonna have to spend my free time literally researching Ohm's law. But that's kind of the purpose of me doing this project, is that if I was doing something that was purely code, I feel like it would be much easier. But it's actually been fun building circuits because I literally have no idea what I'm doing. So, bro, this scale, I mean, I'm pretty proud because it was very accurate. It was actually more accurate than the kitchen scale that I like bought and was professionally built. But I'm pretty proud of being able to create the scale because I literally had no idea. There was the tutorial that I was using had the wrong pins listed, so they were listing like what pins you have to use to connect the wires to, and it took me so long to debug that because I'm not an electrical engineer. I'm so surprised that I was able to figure out the correct pin that I was supposed to go into, but we did make it happen. So where am I? Software setup. I don't think there's I already have the IDE. Okay. For this next section of the guide, we will need to install some extra packages and change some software settings within Raspberry Pi OS. This will allow our Raspberry Pi single board computer correctly communicate with the ADC. I don't need the ADC though. Yeah, I don't. I can skip this. Yeah, I don't need the specific package that's being used to communicate with the ADC. Looks like they have a second one as well. Okay, yeah, I can skip all that sections. So it looks like I honestly have everything set up. I already have the Raspberry Pi set up. I already have the ID ready. I wish I ordered this, but I'm just missing the resistor. But it sounds like I won't be able to do much until I have that, which is frustrating, but at least the next step is pretty straightforward. So then I guess the next steps will be I can get the resistor, complete the circuit, and then yeah, I can probably start running this script. And yeah, so I guess the next step after that would be I do have the scoreboard. So instead of just printing out a string, which I don't need, I'll see if I can actually connect the scoreboard to this breadboard. And then once I'm pressing, I will register a 1 on the scoreboard. And then once I lift up my finger, it should go to 0. Yeah, I think that's I think it's time to end the stream, actually. That actually passed pretty quickly. I'm surprised. I've never done a live stream before. It's been over an hour. I kind of lost track of time. I figured I was going to look at the time and it'd be 20 minutes, but yeah. And we got 4 views. It's not bad. You too. You too, man. Yeah, I'm gonna head out. I'll see ya.
Do incredible
Bye, all
ingredients of the
4
freshest
people.
quality food